Hi friends, welcome to STUDYHIGH.Pk and subscribe, keep in contact for more videos and update. Today we are going to start our next lecture, lecture 5, chapter Heart Medical Physiology. In this lecture, we will discuss the mechanism of rhythmical excitation of SA node, whose generation of action potential in SA node, also called natural pacemaker, is different from the ventricular muscle's action potential, and why there is a delay between the transmission of impulses from SA node to AV node, why arteria contract first and then ventricles are different types of concepts you will came to know after completion of my discussion on this lecture. First of all, I like to inform you the location of SA node. How you can came to know that where SA node is present. If this is your heart or any person's heart, this is an opening of superior vena cava. It opens in the posterior wall, like if it is a anterior wall and just behind is a posterior wall of arteria. Then what happens? The opening of superior vena cava is here. If superior vena cava is open here, it is the location of opening of superior vena cava on the posterior wall of right atrium. Then the location of SA node is just a little lateral and below to the opening of superior vena cava. So first of all, you must know that SA node is located on the posterior wall of right atrium. One is anterior wall, one is posterior wall. It is located on the posterior wall and just below and little lateral to the opening of superior vena cava. So this is the location of SA node in our human heart. As I have discussed, I just want to recall my previous lectures whose action potential is generated in ventricular muscles. Ventricular muscles consist of two types of channels. One, fast sodium channels, just assume this is a fast sodium channels. And second, in heart, there are L-type slow calcium channels. These are L-type slow calcium channels. So, what is the normal resting potential of ventricular muscle? Resting membrane potential, in which inside is negative and outside is positive, is minus 90 millivolt or between minus 85 to minus 90 millivolt. It is the resting membrane potential and some other important things that I have explained you in previous lecture. So these are the some important values that you must remember if you want to understand the different type of concepts related to generation and transformation of action potentials. I have also explained you in detail how action potential is generated or can be transferred from one cell to another cell, or what is the role of intercalated discs in transformation of action potential from one cell to another cell. So first of all, the resting membrane potential of ventricle is minus 90 millivolt or between minus 85 to minus 90 millivolt in normal conditions, whereas resting membrane potential for SA node is minus 55 to minus 60 millivolt. It is the resting membrane potential for our natural pacemaker. And threshold potential, the minimum potential required for opening of fast sodium channel is minus 70 millivolt. It means that when any cell who is in normal conditions, whose resting membrane potential is minus 90 millivolt, when from some outside source or from some its neighbor cells through intercalated discs, positive ions got enter into the cell and its potential become less negative, and when its potential reaches to minus 70 millivolt, which is a threshold potential for opening of sodium channels, Then what will happen? Sodium channels will open, and as you know that a large amount of sodium ions are present in extracellular matrix. These will start moving to the inside of the cell. As a result, inside will become more positive and will reach to plus 20 because of rapid movement of sodium ions into the cell. So as a result, you must also know that this is a L-type slow calcium channels. I have also explained you the different types of channels. L-type calcium channel, which are slow to open and slow to close, whereas another type of calcium channels are T-type channels. We have also explained you the slow and fast potassium channels, etc. So during generation of axial tension, what happens? First, it is a resting membrane potential which is minus 90 millivolt due to movement of some ions from its neighbor cell, because this is in action potential form, and the cell which is in action potential form or depolarized form has more positive inside, and through intercalated discs, through gap junctions made of connexon proteins, these ions will start accumulating into its neighbor cell, which is in resting condition. When the resting membrane potential of this cell will be disturbed because of movement of ions from its neighbor cell, when it reaches to minus 70, which is threshold potential for opening of sodium channels, a large amount of sodium will start accumulating into this inside of this cell, and when it reaches to minus 40 millivolt, because of movement of ions, sodium ions from extracellular matrix into the cytoplasm or cytosol of this cell, when it reaches to minus 40, calcium channels will also open. Because of movement of sodium ions, action potential will be reached to plus 20. But when it is moving through this area from minus 70 to minus 40, and when it crosses minus 50, sodium channels start closing. Sodium channels start inactivating. So until all the sodium channels become inactivated, the inside membrane potential of this cell reaches to plus 20. This is really what is happening in ventricular muscles. No, you should know the basic mechanism. Now we are going to discuss how action potential is generated in SA node and how it is different from ventricular muscles. First, you must know how SA node is different from other type of cells. This is an SA node, sinoarterial node. It has less diameter as compared to other arterial muscles. Its diameter is 3 to 5 micrometer, whereas the diameter of most of the fibers of the arteria is between 10 to 15 micrometer. So it has less diameter. This is the difference between SA node and other muscle fibers of arteria. Second thing that you must know that it has no or almost negligible contractile units or myofibrils which involve in contraction. So its purpose is not to contract, but its result has no or zero approximately contractile units, myofibrils, actin and myosin. So its function is to generation of action potentials, and as the arterial muscles are connected with SA node through are closely connected through intercalated discs. When action potential generated into SA node, it will automatically transfer to its neighbor arterial muscles through the intercalated disc, as I have explained you in first two lectures. And the third important thing, that is the cause of self-excitation of SA node, is that its cell membrane is naturally leaky or permeable to sodium and calcium ions. Now I am going to give you the concept why it has less negative resting membrane potential as compared to ventricular muscle. So because its cell membrane is permeable to calcium and sodium ions, so they can move with ease inside of the cytoplasm of this cell. As a result, its resting membrane potential is minus 60 millivolt, not minus 90 millivolt as occurs in ventricular muscles. So this is the first thing, that its cell membrane is different from other types of cell membranes of arterial muscles and ventricular muscles, as it is permeable to sodium and calcium ions. And when sodium and calcium ions start accumulating inside, slowly its action potential become less negative and it start moving from minus 60 towards positive. As a result, what will happen? Because it is leaky to sodium and calcium ions and its inside become less negative. When it start moving from negative 60 millivolt towards plus 20 millivolt, because of a passive accumulation of sodium and calcium ions inside of the cytoplasm of this cell. When it reaches to minus 40, what will happen? First thing, the sodium channels that are already in closed form. Why fast sodium channels are in closed form? As you know that the threshold potential for sodium channel is minus 70, and when it reaches to minus 50 or minus 60, sodium channels fast sodium channel will close. That's why sodium channels cannot participate in the conduction system of SN node or generation of action potential in SN node, because its normal action potential or its normal resting membrane potential is minus 60, which is the closing or inactivation potential of threshold of sodium channels. So minus 60 is not only the, or minus 55 millivolt is not only the resting membrane potential of SN node, but it is also the closing potential of sodium channels. So there are two things. First, this cell membrane is permeable to sodium and calcium ions, which involve in reducing or cause of minus 60 millivolt to become towards the positive potential plus 20 millivolt. Second, fast sodium channels has no role in conduction of sodium to the inside or outside, because at this resting membrane potential, fast sodium channels are inactivated and always remain inactivated. It is the only calcium channels. So fast sodium channel has no role in conduction of action potential. It is the only L-type calcium channels that involve in generation of action potential in SN node. These two things you must know or remember. This will help you in our discussion, in understanding the discussion in our coming lectures. So first of all, when, because the cell membrane is leaky to sodium and calcium ions, as a result, the resting membrane potential of SN node, which is minus 60, it will start moving towards the positive potential when it just crossed the minus 40 millivolt. What is minus 40 millivolt? It is the threshold potential for opening of L-type calcium channels. So when it just crossed the minus 40 millivolt, calcium channels that are present in the cell membrane of this SN node membrane, they will open. As a result, more calcium will start accumulating inside the cell of SN node or natural pacemaker. So inside become more positive as compared to outside. As a result, what will happen? Action potential has been generated and membrane become more positive to the inside as compared to the outside. So in this way, action potential has been generated. Now inside of the cytoplasm or inside of this cell, which is a cell of SN node, become more positive, and it is connected through the intercalated disc to the neighbor arterial muscle cell. As a result, what would happen? The positive ions from this cell will start moving into the its neighbor cell through the gap junctions or intercalated discs, and that will cause initiation of action potential in its neighbor cell as well. So this mechanism we have already discussed. Now we are going to discuss the resting membrane potential, again generation of original position of the cell. So as this is a cell membrane of nodal cells, because of opening, first thing is the movement of sodium and calcium ions into the cell, which is the natural leaky nature of the cell membrane of node. And when its inside potential reaches to -40, L-type calcium channels that are present in its cell membrane will open. As a result, what will happen? Calcium that is present in its membrane, in its extracellular matrix, will start moving to the inside of the nodal cell. As a result, inside become positive, outside negative. Action potential has been generated. This action potential will be transferred to its neighbor arterial muscle cell, and because all arterial muscles are in syncytium, so action potential will be transferred to our arterial muscle. So this is the mechanism. Now there are a large number of potassium channels also present. So when action potential has been generated, inside become more positive, outside become negative. These calcium channels, L-type calcium or slow calcium channel, will close. They start closing. When they start closing, then calcium incorporation or permeability of calcium to the inside will be blocked, and calcium channels will open. These are the calcium channels. So when calcium channels are opening, a large amount of calcium will start moving. So here these are the potassium channels, and these are potassium channels. And when action potential has been generated, inside become more positive as compared to outside, then L-type calcium channel will close. As a result, potassium channel will open and potassium start moving to the outside of the cell. A large amount of key positive ions, when moved towards the extracellular matrix, again inside will become negative, and the resting membrane potential, which is -55 to -60 milliwatt, will be restored in SA node. And when the action potential has been over, inside become more negative as compared to outside, like in previous conditions. Again sodium and calcium ions will start accumulating inside the cell, because the cell membrane of SA node is naturally leaky to sodium and calcium ions. So this is the basic mechanism, basic step which cause the SA node to self-excite. If you notice, this cell of SA node does not need accumulation of any cell or does not depend on any its neighbor cell for generation of action potential. There is no transfer of any positive ions from some other cell into this cell through intercalated disc, because there is a self-excitation mechanism of SA node. Why? Because it is naturally leaky to sodium and calcium ions. And second thing, it does not need a lot of calcium for contraction, because it has no role in contraction. Its only purpose is to generation of action potential and transfer to its neighbor arterial cells, and through its connected bands, interarterial bands, and through the conducting fibers from SA node to AV node to the AV node and ventricles. So there are some different types of structural difference in SA node which make it self-exciting organ or natural pacemaker of the heart. Now we are going to draw the graph for generation of action potential in SA node. First of all, if you know, the resting membrane potential for SA node is -55 to -60 milliwatt. So this is a resting membrane potential for SA node. Then because of its cell membrane is leaky to sodium and calcium ions, and because its the accumulation of sodium and calcium ions or movement of sodium and calcium ion towards the inside of this cell will result in slowly increase in the inside action membrane potential. And when the inside of the resting membrane potential reaches to minus 40, what is minus 40? This is a threshold potential for opening of L-type calcium ions. When reaches to minus 40, calcium ions will open. As a result, there will be a generation of action potential in this condition. And action potential has been generated because when calcium channels will open, there will be a large number of calcium ions that will start accumulating into the inside. As a result, inside of the membrane potential will become positive, and its maximum positive potential is not plus 20 like ventricular muscle. It is equal to 0, approximately 0. So it has a different action potential situation as compared to ventricular muscles. Its maximum positive side potential is 0, not negative. Then when it becomes 0 or reaches to or below minus 20, the L-type calcium ions will start closing. And sodium channels, as I have explained you earlier, that they always remain closed because the resting membrane potential of SA node is minus 55 to minus 60, which is also the inactivation potential of fast sodium channels. Then the potassium ion channels will open. When potassium channels will open, the potassium present inside will start moving towards the outside. As a result, its potential start decreasing, and slowly it will reaches to the its original minus 55 to minus 60 resting membrane potential. So the potassium causes a repolarization or distortion of resting membrane potential. So this is the simple rest graph I have shown you. First there is a resting membrane potential, and because of permeability or very high permeability of membrane of sinoarterial cells, sodium and calcium will continuously or passively start moving towards the inside of this cell. As a result, its membrane potential will become less negative. When it reaches to minus 40, L-type calcium ion channels will open and its potential will become positive. And when it reaches to its positive direction, L-type calcium channels start closing. When they closed, calcium or potassium channel will open. And opening of potassium channel will result in a repolarization to the original resting membrane potential, which is minus 60 milliwatt for SA nodal cells. And after restoration of this minus 60, again the sodium and calcium channels will start accumulating to the inside and will reaches the cause the cell to reach a threshold potential for calcium L-type calcium channels. Again there is an action potential, and after that it will result in plus 40 plus 0, and then again opening, and the cycle continues. And the SA node does not need or it does not depend on any other cell for generation of action potential. That's why when animals are killed by some person, its heart will start contracting or continue to contract after its death. After its death of 5 to 10 minutes, for some animals, the heart remain continue to contract because of the generation of action potential, spontaneous generation of action potential by SA node. That's why its heart continue to contract soon after the death of some animals, as you have seen or you will see. So this is our today's lecture on chapter heart, lecture 5. In next lecture we will start discussing the most important and most conceptual thing related to heart: ECG, electrocardiogram, rhythmical excitation of SA node that we have discussed today, mechanism, different type of channels involved in excitation of SA node, why fast sodium channels not involved in excitation of SA node or generation of action potentials in SA node, because at its resting membrane potential they are inactivated, or simply the resting membrane potential of SN node is also the inactivation potential for fast sodium channels, and only L-type calcium channels involved in generation of action potential. And second, SN node or natural pacemaker is a self-exciting part of the heart. Because why? If someone asks you why SN node or natural pacemaker cause its self-excitation, because its cell membrane is naturally leaky to sodium and calcium ions that results in lowering its or increasing its insight or disturbing its resting membrane potential to -40 automatically, which result in opening of L-type calcium ions. As a result, channel will open. There is a accumulation of calcium ions. Soon, calcium ions will close and potassium channel will open, which will restore its original resting membrane potential, which is -55 to -60. So hope you best of luck. Hope you understand today's lecture. Best wishes. Like, subscribe to keep in contact for more videos and lectures. Allah Hafiz.